Okay, it has sound this time. So this is worth a lot of bonus points, and the way it works is I'm going to do the left half of each page, and you're going to do the right half of each page. You get half of the bonus points if you do just the ones I do, and you get the other half if you do the rest. All right, so our first thing on here says I can graph systems of equations. All a system means, right, is that you have two equations, and our solution is just where they touch. And then our last thing to keep in mind is we can have three types of solutions. We can have one solution where our lines cross and there's our solution right in the middle. We can have no solution where our lines are parallel and they do not touch. And we can have infinitely many solutions. Infinite solutions. And this is where you graph one line. And when you graph that second line, you see that it is the exact same line. All right, let's get into the first two examples. So this first one says solve the system by graphing. Our first equation right here already says y equals, so I'm going to go ahead and just immediately type it into Desmos. Y equals 3x plus 6, just like that. I'm going to go ahead and take a look at a couple points, and I'm just going to sketch a picture of that graph. I see a point here at -2, 0, and a point up here at 0, 6. I'm going to go ahead and get one more point. I see one down here. I guess that one's not going to fit on my graph. I see one right here at 4, -6. And with those points, I'm going to connect my lines. And I'm halfway done. All right, let's go to the second equation right here. This second one is in standard form. It does not say y equals yet. So I'm going to do my standard form to Desmos. Standard form to Desmos. I'm going to move my x, and then I'm going to divide by whatever number is in front of y. So my first step, I'm going to move my x term. That's going to leave me right here with -4y equals 12 minus 3x. My second step, I'm going to divide both sides by whatever is still in front of y. In this case, a -4. Cross them out, and I am done. Here is my final answer right there. Y equals 12 minus 3x over -4. I'm going to put that into Desmos so that I can see the solution. Y equals 12 minus 3x over -4. There you go. And I can see a couple of good points highlighted for me, so I'm going to go ahead and add those to my graph. I see a point at 4, 0, a point at 0, -3, and a point at -4, -6. I'm going to connect my dots, and there is the system. And I can see that this system has one solution, and that is right there where those lines cross. On Desmos, it is right there at negative 4, 6. On my graph, it is right there at negative 4, negative 6. So that's my solution, negative 4, negative 6. I'm going to write it right here, negative 4, negative 6. Your question, that's pretty much the same thing, is right here. So that's the one you're doing for the other half of the extra credit. All right, let's keep going. This one down here says, the following system of equations will be solved by graphing. James thinks there is no solution, while Rebecca thinks there are infinitely many solutions. Then it says, who do you agree with and why? So first thing I notice is this first equation already says y equals, so I'm going to go ahead and just graph it in Desmos immediately. We have y equals negative 3/4 x plus 2. All right, and that second equation is in standard form, so again, I'm going to use this to go from standard form to y equals. Step 1 is going to be to move x. That leaves me with 8y equals 16 minus 6x. Leaves me with 8y equals 16 minus 6x. Second step is to divide, so I'm going to divide both sides by whatever is in front of y. In this case, 8. Divide both sides by that 8, and I'm ready to put this into Desmos. I'm left with y equals 16 minus 6x over 8. So I have y equals 16 minus 6x over 8. Okay, and if you notice, it looks like there's only one line here. No matter how much I zoom out or zoom in, there is only one line showing. And if you really paid close attention, you'll see that the first line was purple, and when I graphed the second line, it turned black. So both of the lines are there, they are just on top of each other. So again, I have one line that looks like that, and then I have another line that is right on top of it. So when we graph our lines and they are the same, that is right here up on top, and that is called infinite solutions. So I would say I agree with Rebecca. Because they are the same line. Okay. And that leaves you with one more graphing question to do. All right, let's take a look at the next section. The next section, there is one question on your test that looks like this. It says you can solve systems using substitution. So, with substitution, it's really, really good to use in this one specific case right here, and that is when one of your equations is already solved for x. We don't usually solve for x, so it's really good to switch it up and use this different way to solve it. One thing I want to say is this equation is just wrong. This isn't what we wanted. We wanted x equals 5y minus 3. But either way, we have x equals 5y minus 3. And in our equation up here, we have an x. So what we can do is we can take this x and substitute it where x goes. Again, x equals 5y minus 3. So I can take this 5y minus 3 and substitute it in for x. And that would look something like this. I'm going to take this equation and rewrite it. Negative 2x plus 5y equals 22. But again, instead of x, I'm going to use what I know x is equal to. So I'm going to say negative 2 plus 5y equals 22. And right here is where x was. And again, x is 5y minus 3. So I can plug in 5y minus 3 right there. And at this point, what you would use is your equation solver, which you get in the calculator using math and then arrowing up. And if you don't know what I'm talking about, I am talking about this right here, the equation solver in your calculator. This is what you would use. Now, obviously, we can't use it right here, but what you would do is you would go ahead and just type in your equation using x's instead of y's. So we would type in right here, we would type in negative 2 times 5x minus 3 plus 5y equals 22. We would click our OK button or our graph button 2 times, and it would tell us that y equals negative 3.2. And that would be our answer, because our question said, what is the value of y? And there is one question on your test like that, so don't freak out if you don't remember how to do that. But you have this one right here if you want to give it a shot. All right, let's take a look at the next thing on our test. And that is right here. It says, I can write systems, given a table, graph, or a description. All right, I'm going to show you this one, and again, you will do this one over here. It says, line J is shown on the coordinate grid. The table of ordered pairs represents some points on line H. When you see something like this, either a table and a graph, or 2 tables, and you're writing equations, a good thing to know is they are always in the same order. Whatever comes first is your first equation. Whatever comes first is your first equation. And whatever is written second is your second equation. Whatever is second is your second equation. Okay, knowing that, Desmos is going to be really, really helpful. I can go ahead and take this first table on here and put it straight into Desmos, which is what I'm going to do real quick. Negative 16, negative 8, negative 4, 12 for my x's. My y's are 7, 1, negative 2, negative 14. And just like that, Desmos put all of those points right in there. What I can do next, so I have my points plotted in there. I'm going to check which of these equations matches those points. So I'm going to check equation A. Equation A is not ready to be put into Desmos yet. I'm going to go ahead and convert. 4x plus 3y equals negative 15. Subtract 4x on both sides. Going quickly because we've already done this a couple times in the review. Negative 15 minus 4x, divide by 3. Okay, now I'm going to plug that into Desmos and see if it matches the table that I put in. Negative 15 minus 4x over 3. And if you see, that black line does not go on all of the green points. So that is not my answer. Simple as that. Not my answer. Does not match. Now, obviously, if this was the test, I would know it's B, but your test has a lot more answer choices, and I want you to see what the correct answer looks like. So I'm going to go ahead and solve out B real quick. We have 3x plus 4y equals negative 20. Subtracting x on both sides. 4y equals negative 20 minus 3x. Divide by 4. And that leaves me with y equals negative 20 minus 3x over 4. Let's go see if that matched our table. Y equals negative 20 minus 3x over 4. And as you can see, that line goes perfectly through those 4 points from the table. And since it goes perfectly through those green dots, that is my answer. That one is A. So that is B. Now, if you notice on this one, we did not have to check the graph, but we could check the graph, or we might have to on a test question. And the way you check the graph is by first finding a couple points on the graph. Those points will actually be given to you on the test, but we have a point here at negative 4, 6. And we have a point down here at 4, negative 4. So I can do this the exact same way. I can add a table into Desmos with those 2 points. And I can go ahead and check my equations. Now, we already know what the answer is, so I'm just going to go ahead and convert this equation on B really quickly. That would give me y equals 4 minus 5x over 4. And if I were to put that into Desmos right here, y equals 4 minus 5x over 4, you would see that that line passes perfectly through those 2 points. So I would know that is my correct equation, and again, it is B. That leaves you with 1 to try on your own right here. I'm going to go ahead and give you a head start. Remember, if you see a negative y, there is really a negative 1 right here. If you see a plus y all by itself, there is really a plus 1 right there. So again, right here, what you are doing is putting this table into Desmos and then checking which equation matches. All you really have to do is line A, and then you'll have your answer, because these two are different. Alright, let's keep moving. We're about halfway done. Our next one says, I can write and solve systems from real-world problems. This just means from word problems. So the first thing I'm going to do is go ahead and read this question out. It says, Fish and Fins sells clownfish and angelfish. The clownfish cost $1.50 each, and the angelfish costs $2. At the end of the day, Fish and Fins sold a total of 156 fish and made $260. Let X represent the number of clownfish and Y represent the number of angelfish. How many angelfish, so that was our letter Y, were sold that day? So, in this equation, or in this system, I guess I should say, or this word problem, we have 2 totals. I have a total of 156 fish and I have a total total dollar amount of $260. From there, I can go ahead and work on writing my equation. I have some money right here, $1.50 for clownfish, which was X. So right here with my money, I can say $1.50x. I also have a dollar amount right here for angelfish, which was Y. And there is my money right there. I have money, 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 money. I have no more numbers in my problem, so the only thing I can really do for an equation is just my variables. My number of clownfish plus my number of angelfish gives me my total number of fish. X was fish, Y was fish, 156 fish. All that's left to do is go ahead and graph and solve the system. So we've solved for Y a couple of times already in this review, so I'm going to do this one pretty quickly. My first step is to move X, and I am left right here with Y equals 156 minus X. And just like that, it already says Y equals, so this equation is done. I can put that in Desmos. Y equals 156 minus X. There we go. Let's do the second one real quick. Again, nice and quickly because we've done it a couple of times. First step is to move X. Cross it out. We are left with 2y equals 260 minus 150x. Step 2 is to divide by whatever is in front of y, in this case 2. Cross it out, and we are done right there. Y equals. I'm going to go ahead and place that second one in Desmos. Y equals. We have 260 minus 1.5x over 2. And there is my system right there. I can see where those lines cross right here at 104.52. So my solution is 104.52. But if I go reread my question, it said how many angelfish? And angelfish were Y. So my answer is actually the Y value right here. My answer is just 52. So my answer is 52 angelfish. Done. Okay, that leaves you with one to try out on your own. It follows the exact same pattern. And actually follows the exact same pattern as one of the free response questions on your test. All right, we're almost done. We have a couple more to go. This one says, I can graph the solution set to inequalities. Okay, your inequalities. I know y'all don't have this chart. So, real quick, we have our greater than and our less than symbol are greater than or equal to, are less than or equal to. These two symbols here are going to be dashed. These two symbols here are going to be solid. We have our greater than. We also have our less than symbols. These will be shading above. These will be shading below. And let's go ahead and get graphing. It says graph the inequality, then determine if each ordered pair is in the solution set by writing yes or no. Okay, first things first, this inequality is not ready to go in Desmos, so I'm going to go ahead and convert it. Step 1, move x. Gives me 6y is greater than 12 minus 4x. Step 2 is to divide by whatever is in front of y, in this case a 6. And that gives me what is ready to type into Desmos. Y is greater than 12 minus 4x divided by 6. So I'm going to go ahead and type that in. Y, remember it can't graph those inequality signs, so we have y equals 12 minus 4x over 6. And just like that, I have my inequality. I'm going to go ahead and use those 2 points it gave me and graph it. Zero, 2, 3, 0. I see some other points on here. Negative 6, 6. If you're having trouble seeing those points, you do not have to use more than just those 2 that are given. Okay, you do not have to. I do see one down here, though, that I want to use. 6, negative 2. I just want my line to be as straight as possible. I'm going to connect the dots. Okay, I almost missed something. It is kind of late. So, right here, I need to take a look at my symbol. My symbol is a greater than sign. Greater than will mean a dotted or dashed line and shade above. So I should be connecting these dots with a dashed line, and I should be shading, that was a dashed line, shading above. So I'm going to go ahead and color in above my line. Okay, from here, I'm going to be determining if each ordered pair, if each point is in the solution set, so in the shaded in region. Now, if you do not know where these points go, you can use Desmos. So in Desmos, I'm clicking these settings, okay, these settings up in the top left, and I'm changing this line to be a dashed line so that I can see it better. I can plot points by adding a table, and I can just put these points in. There's point for A, right there. And it shows me exactly where that point goes. So right here, point A, it looks like it looks like it goes right here at 5, 3, and it's up on top of the line in the shaded part, so this one is definitely in the solution set. I can do another point. Let's try point B. Point B, negative 2, 1. I can see that this one is under the line, negative 2, 1 over here. So since it is not in the shaded part, it is definitely not part of the solution set. And I can plot this last one on here. 6, negative 2. And I can see that that dot actually falls on my line. Okay, on my line. Right here, 6, negative 2. And since it is on a dashed line, that will not count. If it was on a solid line, it would count, but this is a dashed line, so it does not count. That leaves you with one to try on your own, same type of way, and you have this here if you need it. I'm actually going to go ahead and pause here. I feel like that is a lot for today. So the rest of the questions I'll post in a separate video. So you will just have to go look for that separate video after about a day or so. Okay? It'll just be titled, Cycle 2 Exam 2 Review Part 2. But I'm going to go ahead and stop here.